Hello everyone, welcome back to my channel. Today we will talk about production of penicillin. Starting with the introduction, we all have one point or the another heard about penicillin for sure. In World War II, we all know that the penicillin was the antibiotic which was extensively used and also got the Nobel Prize for Medicine in 1945. It is also known as miracle drug because of its extensive use. Without further, let us take a look at important aspect that how the industrial production of penicillin takes place. So, penicillin was the first true naturally occurring antibiotic ever discovered, a great medical breakthrough. Groups of antibiotics produced by the Penicillium fungi. It is important of closely related compounds, not a single compound. For example, amoxycillin, ampicillin, phenoxymethyl penicillin, around 50 drugs that are penicillin. Now, talking about its history, discovery and production. In 1928, a biologist Alexander Fleming discovered that the Streptococcus culture he had mistakenly left grown in open was contaminated with a mold which has destroyed the bacteria. After isolating a sample and testing it, he found that it belongs to the Penicillium family. Later, the mold was classified as Penicillium notatum. At first, it was difficult to convince people about its potential uses, but later, in 1939, using Fleming's work, two medical researchers known as Howard Florey and Ernst Chain managed to purify penicillin in a powdered form. In 1941, they successfully treated a human. In 1943, they produced penicillin on a large scale. This helped immensely to treat casualties during the World War II that had bacterial infections due to their wounds. This is the structure of penicillin. The penicillin structure have beta-lactam functional group, thus it belongs to the beta-lactam antibiotic group. They have a basic ring-like structure, that is beta-lactam ring, which is derived from two amino acids, vanillin, cysteine, and the third amino acid of the tripeptide is replaced by an acyl group R. The nature of this acyl group produces specific properties on different types of penicillin. It also contains thiazolidine ring. Now, talking about the specific conditions for the production of penicillin, most penicillin form filamentous broths. This means they can be difficult to mix due to their high viscosity. Also, the increasing viscosity of the broth can hinder oxygen transfer. A solution for the viscosity and the filament growth of Penicillium species could be bubble clumps, which would distribute the oxygen equally and also to agitate the medium. Penicillin is an aerobic organism. Oxygen supply is critical. Reactor must have an efficient oxygen supply system. The pH for the penicillin growth is 6.5 and we have to maintain the pH. Stain stability problems, carefully stain maintenance is required. Biomass doubling is about 6 hours. The media required for the production of penicillin should provide all the elements required for the synthesis of cell material and the formation of desired product, provide favorable environment for the culture in question, and should be cost effective. These are the conditions that has to be maintained for the optimal growth. pH should be 6.5, temperature 20 to 24 degrees Celsius. Oxygen should be there, nitrogen. For nitrogen source, corn steep liquor 8.5%, glucose 1%, 80% ethanol, phenyl lactic acid, propionic acid, lactose 1%, calcium carbonate 1%, sodium hydrogen phosphate 0.4%, antifoaming agent is also used, and for antifoaming vegetable oil can be used. Now, microorganisms require carbon, hydrogen, oxygen, sulfur, and nitrogen for cell growth and its maintenance. Also requires small amount of trace elements, and the trace elements like copper, magnesium, etc. Or growth factors are also required, such as vitamins or amino acids. Certain organisms such as Penicillium chrysogenum that produce antibiotics, enzymes or other secondary metabolites frequently require precursor like purine, pyrimidine bases or organic acid to produce certain organisms such as Penicillium chrysogenum that produce antibiotics, enzymes or other secondary metabolites frequently requires precursors like purine, pyrimidine bases or organic salts to produce metabolites. Now, what is primary metabolite and secondary metabolite? Primary metabolism is the metabolism of energy production for the cell and for its own biosynthesis. For secondary metabolism regards the production of metabolites that are not used in energy production. For example, penicillin from Penicillium chrysogenum. The metabolite is being utilized as a defense mechanism against other microorganisms in the environment. Penicillium chrysogenum can kill off the competition to allow itself to propagate efficiently. Now, production of penicillin. Penicillin was the first important commercial product produced by an aerobic submerged fermentation. First antibiotic to have been manufactured in bulk. At the end of World War II, penicillin was first made using the fungus Penicillium notatum, which produced a yield of 1 mg. Today, by using a different species known as Penicillium chrysogenum and better extraction procedure, the yield is enhanced to 50 mg, which was before 1 mg. Now, the industrial production of penicillin. This can be broadly classified into process, namely upstream processing and downstream processing. Upstream processing refers to process before input to the fermenter and encompasses any technology that leads to the synthesis of a product. It includes the exploration, development, and production. Downstream processing refers to process done to purify the output of the fermenter until it reaches to the desired product, such as extraction, purification of product from fermentation. So basically, two types are used, that is upstream processing and downstream processing. Now, medium of penicillin. The Penicillium chrysogenum usually contain its carbon source, which is found in corn steep liquor and glucose. A medium of corn steep liquor and glucose are added to the fermenter. Medium also consists of salt such as magnesium sulfate, potassium phosphate, and sodium nitrate. They provide the essential ions required for the fungus metabolic activity. Medium is sterilized at high heat and high temperature, usually through a holding tube or sterile together with the fermenter. The pressurized stream is used and the medium is heated to 121 degrees Celsius at 30 psi or twice the atmospheric pressure. It is done in a feed batch mode as glucose must not be added in high amounts at the beginning of the growth because it will result in low yield of penicillin production as excessive glucose inhibit penicillin production. The fermentation condition for the penicillin mold usually require temperature around 20 to 24 degrees Celsius, while pH conditions are kept at 6.5. The pressure in the bioreactor is much higher than the atmospheric pressure. This is to prevent the contamination from occurring as it prevents external contaminants from entering. It is necessary to mix the culture evenly throughout the culture medium. Fungal cells are able to handle rotation speed of around 200 rpm. Now about the seed culture. The seed culture is developed first in the lab by the addition of Penicillium chrysogenum spores into a liquid medium. When it has grown to the acceptable amount, it is inoculated from the fermenter. The medium is consistently aerated and agitated. Carbon and nitrogen are added sparingly alongside precursor molecule for penicillin fed batch style. Typical parameters like pH, temperature, sterile speed, and dissolved oxygen concentration are observed. After about 40 hours, penicillin begins to be secreted by the fungus. After about 7 days, growth is completed and the pH will rise to 8 or maybe more than 8 and penicillin production ceases. Now, how we will remove the biomass? Filtration is carried out as a bioseparation is required to remove the biomass from the culture. That is removing the fungus and the other impurities away from the medium which contains the penicillin. A rotary vacuum filter is commonly employed for filtration as it is able to run in continuous mode in any large scale operations. After filtration, phosphoric acid, a non-oxidizing agent, is introduced to decrease pH from 8 to 6.5 so as to prevent loss of activity of penicillin. Now, addition of solvent. Organic solvents such as amyl acetate, butyl acetate are added to dissolve the penicillin present in the filtrate. At this point, penicillin is present in the solution and other solids will be considered as waste, but it can be used as fertilizers or animal feeds. Centrifugation extraction. Centrifugation is done to separate the solid waste from the liquid component which contains the penicillin. Usually a disc centrifuge is used at this point. The supernatant will then be transferred further in the downstream process to continue with Extraction. Disc centrifuge, one of the common type of centrifuge which is used for large scale production. Now, the extraction of penicillin. A series of extraction processes are carried upon the dissolved penicillin to obtain a better purity of the penicillin product. The acetate solution is first mixed with phosphate buffer, followed by a chloroform solution and mixed again with a phosphate buffer, and finally in an ether solution. The penicillin is present in higher concentration in the ether solution, and it will be mixed with a solution of sodium bicarbonate to obtain the penicillin sodium salt, which will allow penicillin to store in a stable powder form at room temperature. The penicillin sodium salt is obtained from the liquid material by basket centrifugation, in which solids can be easily removed. Now we have to dry the penicillin. For drying, fluidized bed drying can be used. Drying is necessary to remove any remaining moisture present in the powdered penicillium salt. In fluid bed drying, hot gas is pumped from the base of the chamber containing powdered salt inside the vacuum chamber in which the already powdered penicillin is kept. Moisture is removed this way, and this results in a much drier form of penicillin, so that the storage can be for a longer period of time. Storage. Now, how to store the penicillin? Penicillin can be stored in containers and kept in dried environment. The resulting penicillin, called as Penicillin G, can be chemically enzymatically modified to make a variety of penicillin with slightly different properties. These can be semi-synthetic penicillin, for example, Penicillin V, Penicillin O, ampicillin and amoxycillin. And now, how we can increase the yield of the penicillin? By adding of the corn syrup, it will enhance the yield. By selection of the strain, because different strains give different yield. So, by selection of a particular strain can give or can increase the yield. Mutation and selection and sexual reproduction as well. Hope you understood about today's presentation, production of penicillin. Thank you.